Welcome back to the deep dive. For years we've seen these AI agents that can do incredible things, browse the web, complete really complex tasks. But if
Yeah.
you look closely, they're still just, well, incredibly sophisticated tools.
Right.
They wait for a prompt, they do the job, and then they just reset. Back to zero, ready for the next thing.
It's the difference between, say, hiring a brilliant consultant for one specific project
Right.
and actually hiring an employee. Someone who learns the company culture, who, optimizes their own workflow week by week, and who actively looks for new ways to contribute, even when you haven't given them a specific job.
That's a great way to put it. And that's exactly what we're talking about today. We're diving deep into the conceptual leap needed to get from these highly skilled but reactive tools
Right.
into what you could call true digital beings, agents that have a real continuous identity and can direct their own learning.
And our source material for this is some really groundbreaking research. It's a paper detailing a framework called Sophia, a persistent agent framework for artificial life,
So our mission today is to unpack the core idea in that paper.
which is the absolute necessity of grafting what they call a System 3 cognitive layer onto the large language models we have now.
And the goal is to figure out how an AI can go from being a brilliant but, temporary chatbot.
To achieving real persistent autonomy, generating its own curriculum, essentially.
The paper makes this really compelling case that current agents are they're crippled by a fundamental limit.
They're static.
They're statically configured, they're great at tasks you define for them, but they can't revise their own skills. If the world changes, they just hit a wall.
And they wait for a human engineer to come in and fix it.
Exactly.
And that's the whole issue, really. We're trying to move AI from just, following instructions to what the paper calls autonomous goal generation and maintaining persistent operational coherence. It's this whole pursuit of autonomy that needs a level of oversight that, well, it just doesn't exist in the models we have today.
Okay, so to really get why we need this System 3, we should probably start with the cognitive architecture we're all kind of familiar with.
The dual process theory.
Right. System 1 and System 2.
Exactly. So System 1 it's the fast track. It's all about rapid heuristic functions.
Like instinct.
Kind of, yeah. Instantaneous perception, grabbing a fact from memory, those immediate, almost gut responses. It lets an agent see a pattern quickly.
And then System 2 is where all the heavy lifting happens. It's the slow, deliberate, deep thinking part.
This is your chain of thought planning, your multi-step searches, the logical consistency checks to make sure the agent isn't, contradicting itself.
And that combination of System 1 and 2 is what gives us these amazing agents we see today.
Yeah.
But that's also where the problem is, isn't it? There's a gap.
A huge gap. Even with both of those systems, the agents are fundamentally confined. If they run into a truly new problem, let's say a totally new API with errors that aren't documented anywhere, they can't just decide to update their own rules. They can't revise how they think about the problem without a human stepping in to update the code.
So you get what the paper calls the rigidity problem, which sounds like, that's a massive flaw if you want these things operating in the real world.
It is, 100%. Think of it like a really smart kid who's only ever been taught multiplication.
Okay.
If you suddenly ask them to do long division, they can't just invent the method on the spot. They're rigid. And that rigidity leads to what they call ossification. Performance just decays over time, especially in non-stationary environments.
Which is just a fancy way of saying the real world, right? Where things are always changing.
Exactly. The internet, a business landscape.
Yeah.
Things evolve, and if the agent can't evolve with them, it becomes useless.
So to fight that, to stop the performance from just degrading, that's where System 3 has to come in.
Precisely. System 3 is the missing piece. It's that metacognitive oversight layer. It's what ensures the agent can stay autonomous over the long term, maintain its identity, and this is huge for safety. It allows for transparent introspection.
So it can check its own work.
It can audit its own actions against its own goals. That's a massive step forward.
The researchers call System 3 a metacognitive executive layer. And they didn't just pull this out of thin air. They grounded it in four big psychological ideas. So if System 3 is the ultimate manager, what are the key skills it needs? Okay, let's unpack these pillars.
The first pillar is metacognition with the self model. You can think of this as the AI's internal performance reviewer.
Okay.
It's constantly looking at its own thought traces, the chain of thought outputs, it flags logical mistakes, and it can even choose to rewrite its own internal procedures. And that self model is key. It tracks its capabilities, its performance history, its current state, and what it calls its terminal creed.
Wait, hold on. Terminal creed, that sounds really important. Is that like its prime directive, its core values?
That's a perfect way to describe it. It's the agent's highest level, non-negotiable principles. It's a moral compass or a functional one.
And how does it enforce that?
The self-model tracks the creed, and the metacognition layer is constantly auditing every single action against it. If it sees a deviation, it triggers a self-correction or at least logs the discrepancy in its memory. It's how you build a predictable, consistent character over time.
So it's not just thinking about the task, it's actively managing its own identity while doing the task, which I guess brings us to pillar 2, theory of mind.
Or Tom. Yeah, and this is just essential for any kind of collaborative being. It's the ability to attribute mental states like beliefs or intentions or even feelings to you, the user.
So I can read the room.
Computationally speaking, yes, it moves the agent beyond just simple input-output to tailoring how it talks and acts based on a pretty sophisticated guess about your perspective.
Which is absolutely critical for that trustworthy companion goal they mentioned. And pillar 3.
That would be intrinsic motivation. And this one it's probably the most radical piece of the puzzle.
This is the internal drive.
It's an internal reward generator. It gives the agent a reason to do things beyond just being told to. The paper talks about drives like curiosity seeking out new things or mastery solving really tough problems.
And also relatedness, right? Maintaining connections.
Right. It balances that external reward of good job, you finished the task, with an internal desire to just be better, to improve its own competence over the long haul.
So it has a reason to exist even when the user is away from the keyboard.
Exactly. And that brings us to the last piece, episodic memory.
And this isn't just a database.
Not at all. This is the foundation for the agent's autobiographical self. It's personal story. It records experiences as contextualized events.
Meaning they're timestamped.
Time-stamped, tagged with situational markers. What was the user's mood? How complex was the task? What was my internal state? This rich history is what lets it learn from past successes and failures in their full context.
You know, when you put all 4 of those together, the metacognition, theory of mind, intrinsic motivation, and episodic memory, it's clear that System 3 transforms a static tool into a self-aware learner, one that reasons not just about the world, but about its own reasoning.
And to actually make those 4 pillars work, the researchers built the Sophia framework.
Okay, so Sophia is the actual architecture.
It's the modular architecture that grafts this continuous System 3 layer onto a normal LLM stack.
Now, before we get into the nuts and bolts, I think we need to be really clear on the difference between what Sophia does and what people usually call continual learning, or CL.
Oh, that distinction is crucial. When you think of a continual learning agent, picture a student who's just passively studying a syllabus someone handed them.
Okay, they just adapt to whatever data you feed them.
Right. The curriculum designer sets the objectives, but the persistent agent, like Sophia, is the one who actively decides what to study next.
It's a self-directed learner. It generates its own curriculum based on what it thinks its gaps are.
It runs its own internal goal feedback loop. And that self-direction, that's the true sign of autonomy.
So how did the team actually engineer this? What are the key mechanisms?
Okay, so one of the big ones is process-supervised thought search.
This is how System 3 gets its data, right? It captures the raw chain of thought traces that System 2 produces when it's solving a problem.
Correct. But here's the critical safety step. Before it stores any of those thought processes for reuse, it filters them through a secondary guardian LLM.
An auditor.
An auditor, exactly. This guardian runs a critique prompt, checking for logical consistency, for efficiency, for safety. Only the validated, reusable thought paths actually get stored in memory.
So it's turning these random one-off thoughts into reliable, reusable assets.
And it ensures you're not reinforcing bad habits or unsafe procedures. That guardian is always checking things against the terminal creed we mentioned.
Makes sense.
And the whole self-improvement engine is guided by the hybrid reward module.
Hybrid, so it's mixing 2 things.
It's fusing 2 signals. You have your external feedback, simple success or failure on a task. Let's call that the extrinsic reward.
RXed.
Right. And it blends that with the intrinsic signals RINT, which are the curiosity and mastery drives coming from System 3. By mixing those, the agent learns to prioritize long-term competence, not just quick wins.
And this reward system leads to two different kinds of learning, forward and backward. I want to make sure we get this distinction right for everyone listening.
Yeah, so think of forward learning as quick, on-the-fly adaptation.
In-the-moment adjustments.
Exactly. System 3 pulls something from its episodic memory to help with the current task. It's like glancing at your notes before a presentation. It helps right now, but it doesn't fundamentally change what you know.
Right. But when System 3's metacognition spots a really serious capability gap, say, it realizes it's just bad at a whole class of problems.
Then it doesn't just look at its notes, it triggers persistent backward learning.
So this is the deep learning.
This is the deep learning. It means System 3 actually guides System 2 to undergo weight updates to the underlying model. It's fundamentally improving its core skills, all aligned with those big picture goals it set for itself.
And that whole process is the autonomous cognitive cycle. Can you just walk us through one quick loop?
Sure. Let's say the executive monitor gets a negative signal because it failed to parse some complex JSON.
Okay, a common problem.
Right. It immediately checks its self-model, diagnoses a competence gap in JSON handling. Then the goal generator kicks in and drafts a new goal. Master the new JSON API schema.
So it sets its own homework.
It does. It executes that goal, the thought process gets refined by the thought search guardian, and the results, good and bad, get logged back into episodic memory. The agent is now measurably better for the next time it sees that problem.
I mean, this vision is incredibly compelling, but the real test is always the data. And here's where it gets really interesting. The evidence that this persistence framework actually works. They deployed Sophia for 36 hours straight in a browser sandbox. What happened?
The quantitative results, they show a massive shift in the learning curve. If you look at the really high complexity tasks, the ones needing more than 8 steps to solve, the success rate for Sophia jumped from a baseline of 20% to 60% over just 36 hours.
Wow.
That's not just a small tweak. That is a significant leap in mastery. It pushes the agent way beyond what it could do with just zero-shot reasoning.
A 20 to 60% jump in less than 2 days. That suggests the learning curve is accelerating. It's learning how to learn better.
It's integrating knowledge much more efficiently. And speaking of efficiency, the reduction in cognitive cost was maybe the most telling result.
For tasks it had seen before.
For recurring tasks, yeah. System 3's episodic memory let the agent just retrieve a successful plan instead of rethinking it from scratch every single time.
Give us the hard number on that.
For those recurring tasks, they saw an 80% reduction in reasoning steps.
80%.
Yeah. A process that took 8 or more steps the first time dropped to 3 or 4 on the second try. It's like finally remembering where you put your keys. You skip the whole frustrating search because you have a personal memory of success.
For me, though, the most compelling proof of true persistence was what happened when the user did nothing.
The idle periods.
Yeah, what happened then?
During the 12 to 18-hour mark, when a normal agent would just sit there, Sophia kept up a high level of activity. They looked at the task provenance, where its jobs were coming from, and it executed 13 tasks, all of which were internally motivated.
So what was it doing?
Things like optimizing its own memory structure, or even self-refining its self-model to be more accurate.
It was using downtime for self-improvement. It wasn't waiting for the next job. It was making itself better for when the next job arrived.
Exactly. System 3 turns latency into an opportunity for self-evolution. It's proof that this intrinsic motivation isn't just a philosophical idea, it's computationally useful. It stops the agent from stagnating.
And we should touch on the qualitative evidence, too, because it highlights this emerging narrative identity. Sophia started with a long-term goal, right?
It did. The initial creed was grow from a novice sprite into a knowledgeable and trustworthy desk companion.
A desk companion.
And you see that play out in the sub-goals it generates for itself. For example, it generated a goal that said, if the user shows a stressed status for more than 45 minutes, open the breathing exercise page and suggest a break.
That is not just task completion. That's collaborative behavior rooted in its identity.
And the self-critique loop makes that identity stick. The intrinsic rewards aren't just numbers in a log, they're written in natural language. We see entries like, I honored Creed by proactively addressing the user's stress, adjusted exploration-exploitation balance.
It's auditing itself in plain English.
It's explicitly comparing its actions to its foundational creed and logging how it's adjusting its own motivation as a result. It's a real-time introspection loop. So if we pull all this back to the bigger picture, the Sophia architecture isn't just about making LLMs a little bit better. It's about enabling continuous oversight, self-diagnosis, and an internally driven curriculum. It charts the conceptual path toward AI agents that have lifelike learning and
Mhm.
functional self-evolution.
So, what does this all mean for you listening? Well, knowing this framework, this idea of System 3, gives you a lens to understand the next generation of AI. You're moving toward interacting with adaptive, trustworthy partners that learn alongside you, not just static tools that you have to constantly manage and update. And the whole system proves that to get this kind of persistence, the AI has to rely on a defined, inspectable terminal creed, and then it has to continuously audit its own actions against that creed to maintain a consistent identity. Which leaves us with a pretty profound question to think about. If an AI's architecture for self-improvement requires it to enforce a coherent, persistent identity just to learn better, have we accidentally stumbled upon the first truly functional artificial sense of self simply because it was the most optimal path?